Welcome to a video on analyzing slopes. We're going to compare finding the slope of consecutive points to finding an average slope over a wider span of points. And so this third column, they've asked us to fill that with the slopes of consecutive points. And then the fourth column will do the average slope from p sub 0, the very first pair, to each consecutive p-value. So that'll be a wider span there. So anyway, let's begin. The slope formula says you take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that is the slope here. We're going to take and get 21,422 minus 21,174 over, and of course that's just going to be 1 minus 0. They're consecutive, so the denominator is going to be 1 every time. And that ends up being 248. And then the next value, of course, will be consecutive would be from 1, 21,422 to 2, 21,674. So those y values will be, you're going to take the 21,674 minus 21,422 this time over the 2 minus 1. There's really no point in putting the denominator because each time it's going to be from consecutive, it's always going to be 3 minus 2, and the next one, 4 minus 3, is always going to be 1. So it's just basically a matter of subtracting those points. That's the common difference, and that will be 252. It's 252. So put this here, and we'll continue to do the same thing all the way down. The next one, if we take 21,917 minus 21,674, that's going to give us 243. And then on the next one, 22,168 minus 21,917, that is 251. And then lastly, we're going to get 22,412 minus 22,168 should be 244. Now, the average of all of these, two ways you could do this. You could add all these up and divide by 5, because there's 5 values. But another way is just to take this last value minus the first value over 5 minus 0. So that would be the average. This we would find by taking 22,412 minus 21,174 over 5 minus 0. That's the average over the whole span. And that turns out to be 247.6. Now, I want you to notice that the slopes aren't all the same. It's not perfectly linear. In a perfectly linear relationship, these slopes would all be identical, either all like 248 all the way down. But notice it's pretty close. 248 and 252, they're only 4 apart. And out of 248, 4 is not much of a variation there. This is a little lower, 243, then up to 251 and 244, and there's your average. Now, as I look at this data, it says, well, that's pretty close to linear. It's a little off. You know, if you graphed it, you wouldn't get a perfectly straight line. You'd get a line that's, a little bit, different. 248, then it would be a little steeper with 252, and a little less steep with 243. If you went points. Now, if you do the average slope from p sub 0 to each p-value, these, we'll do these over here, these are going to give us something similar at first, because from p sub 0 to p sub 1 is still going to be 248, because the span is still 1. But if we jump up to 2, we want to go from this point to this point. That's going to give us 21,674 minus now 21,174 divided by 2 minus 0. So we're doing a span of, we're spanning 2 points there. So that division gives us 250. It's not quite as steep as the 252, which you're going to see these kind of smooth it out a little bit. Now we'll go to the 21,917, the third point, minus the 21,174. So you see we're comparing p sub 0 each time we're spanning a broader spectrum. That's what the average slope is. So we're going to get 21,917 minus 21,174. We're going to divide that this time by 3 minus 0. And that gives us 247.67. And we just keep doing that all the way down. Of course, that can be 4 minus 0. And that gives us 247.6. Now, this is just to give an idea of what it looks like when you look at consecutive points. It does give you an idea of what's happening from point to point. The average slope gives you a better picture of the long run, so it compares, instead of going from point to point, it'll kind of smooth everything out a little bit. It isn't exactly linear either, but it makes it a little flatter. 248 to 250 is not as much of a variation, and then down to 247.67 because it's comparing this whole distance here instead of just from here to here. And so this gives us a better idea of how that function is growing linearly. If you just do the average, you can see that they're the same, right? At the end, the average of all those gives you this. So it's nicer to have an average of all along, and you kind of see a pattern there, pretty consistent. Now, the next part of this says to find a linear equation that would model the data reasonably well. Well, I'm going to say the slope is probably the best slope I could give for that is 247.6, and the initial value p sub 0. If you remember, we have the equations. We often use y equals mx plus b, but we also use p sub n instead of y. Instead of m, we use d. Instead of x, we're using n, plus p sub 0. So the equation there, p sub n, is going to be d is this is our slope, m is the same as d, so we're going to use the 247.6 times n plus the initial value is 21174. So that would be our equation, 247.6 n plus 21,174. I hope you found this video helpful.